The parametric equations of a curve are x equals e to the power of 2t and y equals 4t e to the power of t. A. Show that dy over dx equals 2 multiplied by t plus 1 all over e to the power of t. When finding dy over dx for a pair of parametric equations, we need to do dy over dt multiplied by dt over dx because the dt cancels out to give dy over dx. So what we have to do is separately find dy over dt and dx over dt. For dx over dt, we differentiate x equals e to the power of 2t with respect to t, and that equals dx over dt equals e to the power of 2t multiplied by the differentiation of 2t by using the chain rule. So that gives 2 e to the power of 2t. For dy over dt, we differentiate y equals 4t e to the power of t with respect to t. We can use the product rule to differentiate y because we have two parts multiplied with each other. We can use u equals 4t and v equals e to the power of t. That means du over dt equals 4 and dv over dt equals et, and we just need to put it in the formula for the product rule to get dy over dt. And dy over dt equals 4 e to the power of t plus 4t e to the power of t. And now that we have dy over dt and dx over dt, we can now find dy over dx. Because dy over dx equals dy over dt multiplied by dt over dx, which is the same as dy over dt divided by dx over dt. So we need to divide those two expressions we got for dx over dt and dy over dt. And the top and the bottom of the fraction has common factors, so we can simplify the fraction. And that gives dy over dx equals 2 multiplied by t plus 1 over e to the power of t, just like it was given in the question. B. Find the equation of the normal to the curve at the point where t equals 0. From part A of the question, we are given x in terms of t, y in terms of t, and dy over dx in terms of t. So we want the normal to the curve when t equals 0. So first, we can find the x and y coordinates of that point when t equals 0 by substituting t equals 0 into the expression for x and into the expression for y. So we get x equals 1 and y equals 0. So this corresponds to the x and y coordinates when t equals 0. This means that the normal passes through the coordinates 1, 0. To find the equation of a straight line, we can either have two coordinates or one coordinate and the gradient of the straight line, and we work out the gradient by using t equals 0 for dy over dx. We can substitute t equals 0 into dy over dx to get the gradient when t equals 0. After substituting t equals 0 into dy over dx, we get the gradient at t equals 0 to be 2. And the normal is perpendicular to the curve at that point. Therefore, the gradient of the normal needs to be the negative reciprocal of 2, which is minus 1 over 2. All straight lines can be written in the format y equals mx plus c, where m is equal to the gradient. So now that we have the gradient of the normal, our m equals minus 1 over 2. So we can write the straight line as y equals minus 1 over 2x plus c. And we also know that the normal passes through the points 1, 0. This means that when x equals 1, y equals 0 for the equation. And you can use this to substitute it into y equals a half x plus c to find out the value of c. After solving, we get c equals a half, and we can substitute this c back into the equation of the straight line. That means that the equation of the normal equals y equals minus a half x plus 1 over 2.